Hello everyone. Good morning. Thank you for joining the session and welcome. So hope you all had a good party last night. So I know it is quite tough, when you have such kind of a technical session after a long night party, So considering that we are all having a late after party session, I'll try to make my presentation quite simple and possibly short. Best effort. And also I have quite a few goodies. We can have this session quite interactive and I can give away some of the goodies to you as well. Okay. My name is Abhi George. I work as an escalation engineer for Cisco TelePresence Technologies and Solution. I'm part of Cisco Services based out of Sydney, Australia. I have around 14 years of industry experience in working in telepresence and video communication products and solutions. And I started my career as a developer and involved in quite a lot of developing video conferencing and communication products. Then I moved to an escalation role where I work on resolving complex and critical issues of Cisco telepresence deployments for our customers. And as part of this, I also work with Cisco developers with a focus in improving the product quality and serviceability features in Cisco telepresence product portfolio. So today I'm going to talk about troubleshooting the telepresence experience. So before I get into my details of the session, let me introduce you to one of my avatar. Don't get confused, I'm not a real doctor. I would possibly call that as a telepresence doctor. Whenever I troubleshoot the telepresence issue, I quite often think that I follow a similar process as the doctors follow as part of diagnosing a patient. I have 2 little children. I sometimes take them to the doctor when they get sick. Doctor used to ask me quite a lot of questions related to their lifestyle, work, sleep style, and play style, and various other routines of my child. And sometimes I think they are asking completely unrelated questions to the problem that my child is going through. But I was wrong. A doctor has to understand the complete lifestyle and routine of a child in order to effectively troubleshoot or diagnose a problem and identify the issue and then give a solution to it. Same thing is applicable as far as telepresence troubleshooting is concerned. We have to understand the complete deployment. We have to understand the call flow in order to effectively troubleshoot and identify the root cause of the problem. So I assume that most of you have some kind of a troubleshooting experience with telepresence. It could be as part of your deployment project, or it could be a part of your troubleshooting or as a support role. So I would consider you and me as some kind of a telepresence doctor. So let's begin. So as an agenda, we are going to cover a systematic troubleshooting methodology or approach we can follow as part of our troubleshooting. And also I will discuss about some of the common issues that we see as part of our telepresence deployment, which is signaling issues and media issues, and also run you through the troubleshooting approach and see how we can effectively troubleshoot these kind of issues by using a systematic approach. Tools are very important, so we have to collect a relevant set of information as part of our troubleshooting. So I will also introduce you some of the very useful and important tools as part of our deployment. And also, I'll give you an opportunity to ask question and answer. Or also, please feel free to stop me anytime during this session, and I can answer your questions immediately if the answers are quite short and relevant to this session. And otherwise, you can ask me the questions after the sessions. I'm pretty much happy to explain you one-on-one. What I'm expecting out of this session is to enable you to follow the best practices of the troubleshooting approach, and also utilize the best of the serviceability features available as part of your deployment, and leverage that as part of your troubleshooting, and capture the relevant data at the right time. Troubleshooting telepresence approach. Quite often, we have quite a lot of challenges as part of troubleshooting telepresence issues. So it may be due to the deployment complexity, or it could be due to the type of issues that you see as part of your deployment. So the common things are clarity of the problem. So as a video engineer, you may not be involving in the usage of your telepresence system. So you may get the report from your end users. So you may spend quite a lot of time in understanding the problem clearly. So sometimes you may get a problem report saying that my video quality is not good. But that does not help you to resolve your problem or identify the root cause. So you may have to get more details on it. Getting the clarity of the problem is one of the most challenges that we see in our troubleshooting. Expectations and perceptions. So many times you get issues like related to the expectations. Say sometimes user make a call within their organization and everything looks good and they get a good experience. But when they make an external call, they get a bad experience in the video quality. It may not be due to your TelePresence product or the deployment. It may be due to some of their external link bandwidth issues or it could be a third-party products compatibility issues or various other reasons. So you may get into this kind of an expectation-related issues where user is reporting. Integration challenges. I think it's a very common challenge that we all know, specifically for TelePresence troubleshooting. So as a video communication product, Cisco TelePresence products work with various other standard-based third-party products, including LifeSize, Polycom, etc. And also we integrate with various other third-party solutions, including Microsoft Link or Cisco's own WebEx solutions. So when we work on troubleshooting such an integrated environment, we often get into challenges in isolating the problem. So it could be the problem at the other solutions or it could be a problem on the Cisco solution. So quite often we have such challenges in isolating the problem occurrence. I think most of you would have seen this problem because you get a problem and whenever you wanted to recreate the problem is disappeared. You agree with it? So you get a lot of such kind of a problem. So at this time, you actually struggle in collecting the relevant information because you are not getting the problem anymore. Right? And also, the deploying or appropriate functionality and performance of your TelePresence solution is largely depends upon your environment, including your lighting, acoustics, network, and various other factors. If you do not have all these things appropriately as recommended, you may get into such kind of a problems. Influence from the network. An appropriately provisioned network is very much important for your performance of your TelePresence solutions. So quite often you get into a problem where to isolate where the problem lies. It could be in your network or it could be in the TelePresence solutions. And many times we have network engineer and video engineer. They don't talk to each other. So isolating in such a condition is quite challenging, right? So these are the quite common problems that we see as part of our TelePresence deployment. And I would say it is a challenge, quite challenges we all experience as part of our troubleshooting. Let's see some of the common issues that we see as part of our TelePresence deployment. Predominantly, we have three kinds of issues we see, or three categories of issues that we see as part of our deployment. The first one is system errors. The issues such as high CPU, out of memory, system not responding, system not reachable, application error, cluster error, these kind of errors. These errors are primarily local to that particular device. Say if you have a problem with your VCS, the problem is more local to the VCS. The troubleshooting, such kind of issues are quite simple as far as I'm, in general cases, concerned. Another kind of issues that we see is signaling issue, or we call it as call setup related issues. These issues such as the call doesn't connect, call is turning out to be audio only call getting dropped, external call failure, such kind of issues. So these are all related to your call setup or capability negotiation related issues, where it can involve your SIP or 3-to-3 signaling, or it could possibly involve your SDP or your capability negotiation. So when you troubleshoot these kind of issues, you may get into your entire call flow, because you have to know what all devices where this call flow is involved. You may have to go into gateways, firewalls, and various other components. And such kind of troubleshooting is quite complex. Troubleshooting such issues are pretty much complex because you have to get into a lot of devices, collect various evidences for your problem. The third kind of problems called media issues. The issues involving video patches, video pixelation, video skipping, flickering, and various kind of issues. Troubleshooting these issues are quite complex, or I would say it is a nightmare, because you need to get into the network and see what kind of problem is occurring as part of your network, or it could be a problem with your lighting, various other factors involved in troubleshooting such kind of issues. So now we have set of issues and set of challenges. How do we troubleshoot them? So predominantly we have to know there are two aspects of troubleshooting when you work on such kind of a scenario. One is a systematic approach in identifying the problem, isolating the problem, and collecting the set of evidences, and then finding the root cause of your problem. An approach. And the second aspect is collecting the right set of evidences. Using a right set of tool, you need to collect the right set of evidences from the correct set of devices in order to isolate the problem and identify the root cause of the problem. So let me introduce you to one of the methods that we follow as part of our troubleshooting so that it can be utilized or used as part of your troubleshooting process. So we follow a 4-step methodology called clarify, classify, confirm, and checklist. So this is quite general, but we actually tailored that specifically for telepresence based on the kind of problems and the challenges that we have in our deployment. What is clarify? Clarify is the first stage. We try to collect the information about your problem and define your problem without any ambiguity. So this stage we involve in conversation with the user and ask quite a lot of questions to the users, something like what kind of what, when, and where, what kind of problem that the user is experiencing, and ask quite a lot of questions and get more clarity on your problem. And the second is we ask questions about when does the problem happen. So whether the problem has happened at the beginning of the call or it's in the middle of the call, or when does he see the problem at first and when is he seeing the problem at the last. And also sometimes the problem may be occurring throughout the call or the problem could be occurring at the beginning of the call. So get all kind of information about when does the problem happen. And then also where does the problem is happening. So whether the problem happens at the local side or does the problem happen at the remote side as well. So get all sort of information from the user. And once we collect all this data from the user, it is, as a video engineer, we have to do an analysis on this data. See, as a video engineer, we know what is being expected out of this solution. So we deployed a complete video solution in the network, and we know what is being expected and compare the expectation versus what is being observed as part of the user's experience. So when you have this, you have the problem described very clearly. Another thing which I would like to say is understand the complete deployment of your video network. So you should understand the entire video network and the video flow in order to, or packet flow in order to appropriately troubleshoot a problem. Possibly you may ask, why should I know about everything about my video network when I have to troubleshoot a small issue? Maybe I should explain or answer that with a simple personal example. I've been facing a very severe backache for quite a long time, and I went to a doctor to check my issue. So eventually, as a solution to my backache, I'm actually wearing glasses now. That's a solution to my backache. So you may be surprised, what a completely unrelated solution to a problem. But that's true, because when I met the doctor, he asked me quite a lot of questions about my lifestyle, sitting style, work style, and various other things, which can potentially cause the problem to my back. So he figured out that my sitting posture in my office or in my work is causing a problem. So I was actually sitting in my office and looking very close to computer, which was a wrong sitting posture because I was unable to see the computer appropriately. So he actually forwarded me to an eye specialist, and I got my eye tested, and I figured out that I had a problem with my eyes. So I started wearing glasses, and I'm no more sitting in a bad posture, so I don't have a backache now. So now you have a connection from the problem and to a root cause. The same thing is applicable in the telepresence. You may be seeing a problem in an endpoint, but the cause could be somewhere else. It could be due to your lighting, or it could be due to your acoustics, or various other things, or it could be due to your network. So in understanding the entire deployment is very essential when you're troubleshooting a video experience issues. Once you clarified all your problems and symptoms, next step is to do a classify. So as part of the classify stage, we try to isolate the problem to a very small level so that your troubleshooting can be very much focused. So we have few steps when you classify the problem. So we actually look for a similar working scenario. For example, if you have a video call problem, we also look for a similar working scenario. For example, if your point-to-point call works and your multi-point call fails, so you can classify the problem as a multi-point call. So that then you can compare what's happening between your point-to-point call and multi-point call. That would help you to troubleshoot the problem effectively. Or if you have a problem with when you make a call to an external organization and the calls within your organization looks good, then that means you can classify the problem as a firewall traversal problem, because you have a problem only on external call. So identifying a working scenario, similar working scenario, would help you to classify the issue specifically. And also we have another step called problem isolation. So problem isolation would help you to select a few devices where you can actually collect the evidences from only those devices. So how do we isolate it? Sometimes on a signaling or media issue, look through the call path. So if your call path is involving certain devices, a failure call path is involving certain devices, you can actually go and collect all the data from only those certain devices, do an analysis. So this way, your analysis is more focused. Right? So once you classified the problem to a specific area, next step is to confirm. Confirm is a step where you collect all the relevant information about your problem. So with this information are evidences of your problem. These evidences would help you to confirm that you have a problem, and also it would help you to identify the root cause of your telepresence issue. So this involves collecting logs, collecting traces, and various other evidences from your systems and from your network. And also look for any other problem triggers. Look for any other cases where any configuration changes whether you have made in the recent time, which can potentially cause this kind of a problem. So if you can track any of the previous changes that you have done in your network, that would help you to backtrace and identify any potential cause of your problem. And also, if you have, during the isolation process or during the classify stage, if you have collected any working scenario and collect any data from the working scenario, you can actually compare the working scenario and failure scenario data, and you can actually identify the problem quite easily and quickly. And this step involves the data analysis as well. So you have to analyze the data at this stage. The fourth stage is checklist. So quite often when I work on troubleshooting telepresence issue, I often think I spend quite a lot of time on this troubleshooting, and I could have solved the problem much earlier than this if I had looked into a specific case before, because I missed that stage, so I spend quite a lot of time. You can avoid that if you follow a checklist. Checklist is a simple problem-based checklist where you have a list of evidences that you have to collect, and also you can have a subset of what all items that you have to check, what all items that from that evidence that you have to verify that to confirm your problem. For an example, if you are experiencing a video quality issue, one of the evidence that you have to collect is statistics. So you need to look into the statistics. Few things that you have to look into the statistics in order to identify that you have a problem. You may have to look into the resolution, you may have to look into the bandwidth, you may have to look into whether any packet losses has been observed or any jitter is out there. So those aspects you have to look at. So you should contain a list. You should have a list containing all this information. Right? And you have to verify that you have checked all this aspect. So subsequent presentation will help you to prepare such kind of a list so that you can use as part of your troubleshooting. So now we have the fourth step, which is clarify, classify, confirm, and checklist. Please be aware that these steps are iterative. Anytime during your analysis, you can actually go back to the step and refine your problem descriptions and come back and do the same step until you figure out your problem. So I will take you through a couple of problems, signaling issues and the media issues, and see how we can apply this methodology and effectively troubleshoot the problem. The misconfiguration is the primary cause of the signaling issue. So this is around 90% of the time what we have seen is at the end when we identify the root cause of a signaling issue, this turned out to be a misconfiguration. I assume most of you also have the same opinion. Tell me if you have any different opinions. Anybody disagree with this as far as telepresence troubleshooting is concerned? The misconfiguration could be either in your endpoint, or it could be on your call server, or it could be in your network, firewall, or anywhere. So typically, the main cause of signaling issue is misconfiguration. So let's look into some of the examples here. So we have many signaling issues here where call doesn't connect, one-way media, call drop, third-party call failure, external call failure, quite a few issues. I will take you through one of the single issue and see how we can troubleshoot, apply this methodology as part of our troubleshooting. Traversal zone error. So before we get into the details of the problem, let us first understand what is traversal zone and how does it work. So that's our clarify stage. As part of our first stage, we understand the deployment and then we understand the problem. What is traversal zone? So we have a deployment diagram shown here where we have the call manager and the telepresence endpoints registered to the call manager and the VCS control, both call manager and VCS control connected using a SIP trunk, and both are within your corporate network. And we have a VCS expressway within DMZ, which is a dual subnet DMZ, where the VCS control and expressway is connected there, and further we have internet. And the MCU or telepresence server is being registered to the VCS control. So in order to facilitate any endpoint within your organization to call to internet or to any other corporate network, Cisco has a firewall traversal solution using VCS control and VCS expressway. How does it work? So the VCS control within the organization opens a firewall traversal channel to the VCS expressway using firewall traversal protocols. We use both SIP and 3-3 as a firewall traversal protocol to connect between this. So also we have a firewall here. The firewall we should have a configuration in the firewall such a way that the firewall should open those ports to connect to the VCS expressway. So the VCS control makes an internal to external connection to VCS expressway. Also, in order to keep these connections active, VCS control keeps sending a keep alive signal so that firewall will not disconnect these connections on the inactivity. So the connection should be active always. So when any device within the organization initiates a call goes to the VCS control, then VCS control will take the call through the already established channel to the VCS expressway, then the call goes to the internet. So this is how the firewall traversal call works. Same thing is applicable for the call which is coming from external to internal. It takes the same path and then VCS control then forward the call to the internal devices. Right? So in the VCS design, VCS has segregated all these neighbor connections with zones. So we call this connection, VCS control and VCS expressway connection, as traversal zone. So we have set of configurations to enable this on VCS control and VCS expressway. So VCS expressway, it is called as traversal server zone, and VCS control, we call that configuration as traversal client zone. So when we look into the traversal zone configuration at VCS control, we see the status as active. So both SIP and 3-3 status active, and overall state is also active. So what is expected from this solution? The status should be always active, and all the calls from internal to external and external to internal must work. So this is what we expect out of this solution. Let's look into the problem now. What we see as part of this is we see a failed connection for the 3-3. Right? And also the status says no response from the system. But as far as overall status is concerned, it is active because the SIP status works. The calls are working because SIP connection is already active. The calls are taking the SIP channel. Right? But in certain scenario, we need both SIP and 3-3 to be active. So that's a problem here. So now we are very clear about the problem, and we are clear about our deployment as well. So the next step is classify. Let's classify the problem into a specific area so that we can spend our effort in collecting the relevant information from that devices. When you look into the problem, we classified the problem as a firewall traversal problem because your internal calls are working fine, this is a specific to a firewall traversal problem. So we classified the problem as a firewall traversal issue. And look at another case where we also have a similar working scenario here, right? The SIP is working good. So now we have another classification point called H323 signaling, because we classified the problem as specific to H323. So we focus our troubleshooting specific to H323 now, right? So now look into the problem isolation stage. So we've taken through the call path now. So the signaling works from VCS control to the VCS expressway, right? So we isolate the problem as a traversal zone error, which is specific to these connections here, right? And the problem is specific to the VCS control and expressway communication. And another area that we should look at is firewall, because when you look at this communication, we have a middle guy called firewall. And so now we classified the problem specifically, so we collect the information from only those areas at the moment. So now next step is to confirm. This is where we collect all the information from these devices and do an analysis. So now we look for any trigger. That's usual. We don't get any trigger here because most of our customers say they don't know what they have changed. I think in your case also, if you know exactly what trigger happened for this issue, it would have been very easy for you, or your life would have been much easy as far as troubleshooting is concerned. So don't expect for trigger. It's very rare. But if you get it, that's great, right? And we look for condition. Any specific conditions where this problem has occurred. So what we have done is we connected this VCS expressway to an internal network and did some configuration, and everything looks good, right? So the problem happened only in a condition where VCS expressway is connected to the DMZ. So something to deal with the DMZ. So we figured out that something to deal with the DMZ. So now we look for evidences. So we have to collect certain evidences in order to analyze this data. So we have to collect, traversal zone peer status and VCS expressway logs and etc. So now as part of analysis, we figured out that there are a couple of reasons that you have this problem, right? Possibly one cause could be the VCS control is not sending the connection properly to the VCS expressway, or VCS expressway is not receiving those packets, right? So why VCS is not receiving the packet? There could be a reason that firewall is blocking, right? Or there could be a configuration error in the VCS control and expressway. For example, for the firewall traversal, we have certain configuration on expressway where we specify a port number. So assume if the VCS expressway is expecting the firewall traversal connection on a port X, and VCS control is sending that packet on a port Y, then you have a mismatch. So we need to make sure that both configurations are correct. So what we have done is we collected the configuration backup. We also collected the logs from VCS control and the expressway. So we have two kinds of log available here, event logs and diagnostics log. I will talk about that in detail later, but just for this discussion, let me explain you some brief about these logs. So the VCS event logs are a very brief log which actually capture all the VCS network related events or internal events. The diagnostics logs are very detailed log which contains the packet traces and which contains your SIP packets and your 3-to-3 packet. All these details as part of the diagnostics logs are available, right? So we collected these two logs, and also we collected the firewall configuration. So we need to check the firewall is appropriately connecting or sending these packets or open this particular port or not, right? So we collected these things, and next step is the checklist. So this is a stage where we actually confirm that we have done all our steps in terms of analyzing our problem. So now we look for H323, we checked for a few things there. So we looked into the event logs and diagnostics log, and we checked whether 3-to-3 packet has been delivered to the from the VCS control or not. The log says yes, 3-to-3 packet has gone from VCS control. Has it been received at the VCS expressway? No. So two reasons. There could be a configuration error or there could be a firewall problem. So we looked for configuration backup and checked whether VCS control configuration correct, is he sending to the correct port, and VCS expressway configuration is correct, is he expecting on the right port. Both are good. The next is we need to look into the firewall. So we went ahead and looked into the firewall configuration. Ports are good. So where does the packet go? So the next option is to look into the network and see whether the packet is somewhere missing in the network. So what we have done is we did a packet capture in this case. So this steps of checklist helped us to go to a next step called packet capture, because we confirmed that we verified all the possible causes and nothing is falling here, nothing is hitting. And so next is we need to look for the packet capture. So we look for packet capture and we collected the packet capture from VCS control, expressway, and the firewall. And as part of our identifying the root cause, we look for the packet capture in the VCS control. So something suspicious we have seen here. It says time to leave exceeded responses coming from the VC remote side. ICMP responses received at the VCS control side. That means somewhere there is a loop observed. So when after further tracing, we looked into the firewall packet capture and we figured out that there is a loop observed in the ingress side of the firewall, right? And after further analysis, we figured out that the firewall is sending the packet to a wrong interface. Instead of sending the packet to an external interface, where the VCS expressway is located, firewall was always sending the packet to the internal interface, right? So the problem was complicated at the initial. The problem looks simple, but as part of our analysis, we had to go into all the steps and figure out that there is a problem in the firewall side. Right? So the systematic approach helped us to analyze the problem correctly, identify the root cause. Now what's next? Go and fix it, right? So we would say, no, step back. So before we jump into a fix, we need to do some sort of analysis. Question the cause, question the fix. So there could be possible similar issue in any other places as well. As far as this case is concerned, what customer has done is they have done a copy-paste of the firewall configuration from one firewall to another firewall. So they made a mistake there. So this step helped the customer to look into all other firewalls which involves in the telepresence scenario and making sure that this problem is not present in any other firewall or any other area itself. So you may have cases where you may have the similar problem in various other places. You can apply the similar fix if required to another places as well. Right? So now we looked into one of the issue, which is signaling issue, and let's look into another kind of issue called media issue. Media issue is typically involved in once you establish the call, and you may have a media related issues. So any questions on this as far as process is concerned? Cool? Okay. Now, an important thing about the media issue is a very common phrase, picture is worth 1,000 words and a video is worth 1,000,000 words. So this is a very common phrase, but as far as a video engineer is concerned, this is a golden phrase. Right? We have quite a lot of customers who explain about their video problem. It is quite challenging for us to understand from their explanation. Always a picture or a video capture would always help us to understand what exactly is happening in the field. So I have one of the experience recently from one of our customers in Australia where they reported a problem about their video quality. So we couldn't figure out what exactly that they were facing, and problem description was not clear. We asked for a video capture. But after 1 week, they could provide us a video capture describing the problem. Within next 1 hour of receiving this video capture, we could give them a solution. The customer has to just upgrade that box because it was a non-issue, and they have to just upgrade their CTS device in order to fix the problem. That's the effect. So we always recommend our customers to capture even a video of the problem that they're seeing in their devices and share it with us, right? And an experienced video engineer can look into a video capture and he can actually tell where the problem could be there on the encoder, decoder. He can actually isolate the problem by looking into the nature of the problem that he observed as part of the video, right? That makes a lot of difference, and it will actually save a lot of your time as far as your troubleshooting is concerned. Let's look into some of the video problems that we see here. Video patches, pixelated, blocking, refresh, and so many different categories of the problem. As a user, they may not be able to differentiate what exactly is causing, and they cannot even differentiate this kind of a problem. That's the whole reason we say is take the picture or a video. So I'll take you through one of these examples and see how we can apply our troubleshooting methodology and work on the media problem. Patches. First step, identify the problem without any ambiguity. So this is a picture describing the problem. So what you see here is there are quite a few patches across your video stream, and it's continuous. So there is a continuous video patches observed as part of your CTS call. And also user has looked into the CTS touch panel. So touch panel indicates that there is a heavy packet loss observed. So when you look into the CTS touch panel, it says heavy packet loss. And one particular thing from the user is he is observing this particular issue only at one site. So the customer has multiple sites across various regions, and the MPLS network connecting these branch offices. So each of their site has multiple CTS devices, right? So when they make the calls across different branch offices, they see the problem only at one particular site office. The problem is intermittent. Sometimes you get the problem, sometimes you don't get the problem, right? So we are clear about the problem in a user's perspective, and we also know how the deployment is in a very high level at the moment. Now, let's classify the problem. So we classified the problem as a media issue because signaling went through, everything looks good on the signaling, capability negotiation was good, but we have a media patch issue. And also we know that there is a packet loss in the system, so we observed that as part of our CTS touch panel. So the video patches due to packet loss, we categorize the problem in that way. And as far as isolation of the problem, we look for point-to-point call, and we made a multi-point call. We have problem in both point-to-point and multi-point call. So we cannot isolate in that level now. So the problem is there in both point-to-point and multi-point call. But specifically, the problem is there when the user makes a multi-point, multi-site intra-company call. So when they make a call from one branch office to another branch office, they experience a problem, right? But when they make a call within their branch office, they don't have a problem, right? And the issue is observed only at one particular site. We call it as site A at the moment. So our problem is more specific to site A, and when the site A is involved in making a call with any other site. But when they make a call between site B and site C, they don't have a problem. It's all good. So we isolate the problem specific to site A and site B. So next step is to collect all the data in order to analyze it. So we look for trigger as usual. No trigger. And so the condition we have is multi-site intra-company call when CTS from site A is involved, right? So we look for evidences. We look for packet details about your touch screen and statistics and all these details. So what we essentially collected was we collected the logs from the CTS. We collected the log from site A and site B devices from CTS. And also we collected the packet capture as part of, because this is a network related problem because there is a packet packet loss is involved. So we collected the packet capture also from these devices. So we did some analysis on the evidences that we collected. So we look for the statistics. The statistics indicated that there is around more than 20% of the packet loss. So the 20% of the packet loss is not, it is beyond the tolerance level of CTS. So obviously, if you have 20% of the packet loss, you're going to have a video patch issues. So now our problem is more confirmed that yes, we have a good amount of packet loss, which can potentially cause a video patches. Right? So we used the SysOp logs, which is a very common logs and useful logs available as part of our CTS devices in order to analyze our data. So SysOp logs contain the statistics. So we look for the statistics, and after that, we need to figure out why this packet loss is happening. So we have other logs in the SysOp logs which can give some potential clues for this kind of problem. So we found something suspicious here, that the video DSCP marking is shown as B, and of course the audio DSCP marking is also shown as B, best effort. So essentially, if your video packet is received with the best effort marking, obviously your video traffic can get compromised in your network, right? So we need to see why the packets are being marked with B. Ideally, the packets, we configured our CTS devices in such a way that we have the marking as CS4, not B. So that's a default configuration. We have it in the CTS device or in the call manager. So there are two reasons that you can actually get a BE marking in this case. One, there could be a misconfiguration at the source side, source CTS. He himself is marking it as BE and sending it. Or there could be some problem in the network, or somewhere it is getting remarked. So first thing that we look into is we actually look for the source CTS configuration. So we opened the source CTS configuration and we saw the DSCP marking correct, which is CS4. So the problem could be there somewhere in the network. So the next step is to look into the packet capture. So as part of the checklist, we once again looked through our checklist and made sure that we verified all the points. We saw the packet loss at the destination, and the DSCP marking at the destination is shown as BE. And we looked at the configuration at the source. That is correct. Obviously, the next step that we have to do is looking into the packet capture. So we looked in the packet capture. We found that source CTS is sending the packet with appropriate marking, with CS4. And we look for the destination packet capture. It says 0, best effort. So in the line itself, we see the packet as best effort. So somewhere in the network, it is getting remarked. A further analysis confirmed that we have a switch in the site A, which is actually remarking this packet. Right? So that was a cause for the problem. So what's next? Go and fix on the switch. Now, do an analysis. Apparently, on this case, customer had a small network, video network initially, and they expanded their network to various branch offices. So they were doing a port-based trust. They did not follow that in any of their new branch offices. They ignored it. Because as I said earlier, the video engineer and network engineer doesn't talk to each other. So they did not do appropriate network configuration in their rest of the branch office. Apparently, they did not see this problem in many of the branch office because those branch office network was not busy, so that you won't get the problem now. So, but looking into, stepping back and analyzing the problem and analyzing the cause helped the customer to look around in their all branch offices, and they could fix all the problems so that they avoided a potential future problem. So now we looked into two examples and see how we can apply our troubleshooting methodology and effectively resolve or identify the root cause of our problem. Any questions? As in the approach is concerned? Thank you. Okay, so let's start with some of the evidences. What all things that we can collect from these devices when you experience the problem? So I will take through the signaling and media issues and see what all evidences that you can actually collect when you have a signaling or media issue. So this table shows a list of devices that are involved as part of our TelePresence deployment. And very common and important devices include CTS devices, which Cisco's immersive systems, TC codecs, the room systems, VCS, MCU, and TelePresence server. And many times you get a chance to collect all this information when you have a call. But that is only possible when you're reproducing a problem, right? So when you're reproducing the problem, you can actually look into these information during the calls. But many times you may get a problem report of a past call, which happened in your organization. And so those times you can use the after call options. So these are all the logs available. You can actually look at after the call, once the call is completed, right? And we also have Q&E, which is quality of data for each of these evidences and ease of collection. So let me give you some example on this. So when you look at CTS touch panel, as far as quality of data is concerned, you get okay kind of a data because it will tell you some indicative figure. Say packet loss is bad or good or those kind of information. But when you look into the ease of access is pretty easy because it's just one touch, you get quite a lot of information. But when you see web UI statistics of CTS, that gives you quite a lot of information, including your the time, jitter, delay time, and your percentage of the packet loss, etc. But when you are accessing those, it may take little effort because you have to log into your web UI and then collect those information. And sysop log, it's very useful information. You have quite a lot of information available. 90% of the time, we actually rely on sysop logs in order to identify the root cause. So that will give you quite a lot of information as far as quality of data is concerned, but you need to read through the log. So as far as ease of reading or collection is concerned, a bit complex. So you can actually run through those offline, and you can actually see which all evidences that you may need as part of your troubleshooting. Let me start with CTS devices. As you can see, it is one of the Cisco's best product, which is TX9000. So we have quite a lot of troubleshooting tools that we have available in order to troubleshoot a problem with the CTS. So maybe any questions on the previous, or I should ask a question. So I have quite a lot of goodies to give away. So maybe I should ask a simple question to you guys to get you guys active in the session. So what is the latest CTS release available? You can tell the major release number, that's enough. So I have something to give away. Latest CTS or TX release numbers. Oh, it is one, for CTS release available is CTS 110. Yeah, but you have something matching down here, so I can give a cap. Yeah. Okay. So do you know TX release? What is the latest TX release available? 6. Yeah, 6. I think it is 611 is the latest TX release. 611, yeah, is the latest. Okay, let's continue. So we have few logs available or few evidences that you can collect as part of your CTS devices. Call statistics from the touch panel, which is a very indicative information, high-level information. You can collect the call statistics from web UI, sysop log, SIP messages, quite a lot. And I categorize this into signaling and media issue. You can actually choose which one to collect based on what kind of issue that you are facing, right? And essentially, the packet capture may not be needed for signaling issue because we have quite a lot of information available in the log in order to identify your signaling issue. But in certain scenario where you do not have the logs available, so for example, when you are interworking with a third-party device where you do not have a logs available from the third-party device, you may have to do a packet capture, but only when your TAC engineer instruct you to do, you can actually go for packet capture. But quite many times you may not need a packet capture for signaling issue. So let's start with our touch panel. So this is touch panel gives you very high-level information. It's an indicative information, but this could be used as a first checkpoint if you are on premises. It will give you the resolution, packet loss, latency, and jitter, those kind of information. But it may not be helpful for you to really identify the root cause, but it can be some sort of a trigger or indications for you to go to the next level of looking. So we have CTS web UI call status. It is very extensive and quite detailed information that is available as part of this. It gives you address and port number, what is the DSCP marking, and also it will give you the percentage of packet losses and the amount of time or jitter time, etc. So a lot of information, and codecs, what is the negotiated bandwidth and what is the actual bandwidth, a lot of information. So especially when you are observing a media quality issue, this could be one of the important area there that you should look into, right? So once you have some clue from here, the next step is to look into the sysop logs. There is a common misconception that they think sysop logs are meant for Cisco engineers, but no, we designed this for you, or for our customers and partners, in order to look into the details. Because you do not have to download the logs in order to look into it. You can go to the web UI and go to the troubleshooting and log files. You have sysop logs right there, right? And you can look for the timestamp and run through this logs and see what happens, what was the resolution, what was the frame rate, and what is the DSCP marking, etc. One important thing to note down in the sysop log is timestamp that is written here is in UTC. So you should get your call timestamp and convert that into UTC and then look for that in the sysop logs. It's almost 70 to 80% of the time, we get the problem here itself. Right? And so many times, we get the lead from here, so that we look into a specific logs and identify the root cause. Another important tool in the CTS device is SIP messages. So we have another tab called SIP message, where you can look into those SIP logs here. All logs are logged here. Any of the previous calls logs are also you can figure out here. So we can actually easily click on any of this message. Say, for example, if you wanted to trace one particular call messages, click on an invite message based on your timestamp of your call. That particular SIP message would be opened here in a new window, where you can actually read through all the SIP messages and the SDP values here, STPs here. And what you see below is all the related messages. The related messages is a message which is being sorted based upon your call ID. So what you see as part of the related message is all the messages related to that particular call. So you can actually browse through that in order to identify if you have any problem with your signaling. Right? So you can see whether any of the messages are missing, or if your SDP comparison, you can compare the SDP and see if any problem in your capability or SDP negotiation you had. Right? You looked all these possible ways to identify the problem. Now you need some other help, right? So your friendly Cisco support is available, Cisco TAC. So before you talk to Cisco TAC, make sure that you collect the logs. So another tab here is log files, where you can capture the log from CTS. By default, CTS logs all debug level logs into the system, right? But what you have to do is you have to do a capture of these logs so that it will be made in a tarball and given to you for download. So what you should do is select the problem type, and if you do not know what type of problem it is, just leave it as blank, and then click on capture new logs. Once the capture is completed, it will actually take, during the capture time, it will take all the logs from all the components and make it as a tarball, and it will give you, once it is completed, that it is 100%. Once it is captured, then you can go for a downloading of these logs and share with us. Right? So many times the people forget to do a capture of these logs. So what happens is you will actually get all the data from your previous capture, not to the current problem. So also make sure that we capture this as soon as you see this problem. Right? Or if you're recreating the problem, you finish your recreation, then do a capture and collect the logs. Next is TC codec. So TC codec is our room systems or a general purpose room systems. This is predominantly from the Tandberg acquisitions. Maybe any questions from the previous CTS logs? Oh, okay. So now I should ask a question on this. So what is the latest TC release available? 7.2. So then I should have multiple things. So it's a the correct release is 7.0.2. Okay. Now, in the TC devices, we have call statistics from touch panel, call statistics from web UI. You have Xstatus APIs if you're interested in going into the CLI, and also diagnostics logging and network packet capture. So in the TC devices, the statistics are similar in both touch panel as well as web UI. You don't, unlike your CTS devices, TC devices have the similar touch panel and web UI information. So touch panel is quite extensive. You get quite a lot of information from touch panel itself. But if you are not on premises, you can actually log in from web UI and collect those information from the web UI. In TC 6.x onwards, we introduced a new diagnostics options. It's just very easy for you to collect the logs from the TC devices. So one important thing to note in the TC device is, unlike CTS device, TC device doesn't capture all the debug level logs by default. So what you have to do is you have to enable the logs and then reproduce the problem and then collect this. Right? So the TC device capture the logs only on a very high level or error kind of a log, but TC device doesn't capture the debug level logs. So in order to capture the debug level logs, you need to enable the logs. Earlier what we used to do is we used to go into the SSH and then enable the logs, recreate the problem, and then collect this data. But now from TC6.x onwards, we have a diagnostics mode option available in our touch panels. So go to your touch panel and click on diagnostics mode on. So from that point onwards, TC device will start collecting the logs. So make it on, then reproduce your problem. Once you complete recreating the problem, turn it off, and then go to the web UI and download these logs. So that log will contain all the debugging information available as part of your last call.
You have to turn it off manually, or?
Yeah, if you do not turn it off manually, it will turn it off after 5 minutes or 10 minutes. I think it is 5 minutes, it will turn it off. Oh, sorry, 10 minutes. 10 minutes, it will turn it off. And also, if you can use that if you are on premise, you are at the device. But most of the time, you are going to be in a remote place where you need to use web UI. So when you use a web UI, you have the same options. You can go to the diagnostics and log files. We have an option called extended logging. So you can choose how much time you wanted to turn this log on or off. So you have an option for 5 minutes and 10 minutes. Choose that. Start extended logging. Once you start extended logging, you start recreating your problem. So all the logs during this time are being captured in the TC devices. Once you finish recreating the problem, and you have seen the problem, stop it. If you do not stop, it will automatically stop after 5 minutes. But better to stop because your logs are not getting overwritten. Right? And once you complete this process, you can go to the download log archive and download. So we have 3 options in downloading log archive. 1, without any call history. 2nd, with anonymized call history. And 3rd, with full call history. So anonymized call history doesn't contain your source alias and destination alias, all these things. But yeah, it's based on what option that you wanted to choose. You can choose those and download the logs. But anyway, this will contain the complete information from your last recreate. Next is VCS and conductor. Any question from the previous session? Right? Okay. Latest VCS release. X? Or 8.1. So, okay. Latest conductor release. One more chance. Pardon? 202. Yeah. Thank you. Okay. Now, we have quite a lot of information in the conductor to collect. Call history, call status, we have diagnostics log, maintenance. There are quite a lot of maintenance tools are available, and also network capture by default. The important thing when you experience any signaling issue, you need to capture the search history from the VCS. Search history is the first point that you should look at in the VCS troubleshooting. Now, when any calls reaches to the VCS, you will have an entry into the VCS. So assume if you made a call and there is no entry in the search history, that means the call hasn't come to VCS or it is somewhere in the line. So you can look behind VCS and see what happened before VCS. But if the call has come to VCS, VCS will run a search rule, and if matches any rule, then it actually will show you found, and it will actually forward to the respective neighbor based on the configuration in the search rule that you have. So assume if you have a status found and you still does not have a failure, sorry, if you still have a problem with your call, then you may have to go to that particular neighbor. So you can actually click on view and see what all actions that VCS has taken and which neighbor he is forwarding the call. So you can figure out which neighbor is a next leg of the call, then go to that particular neighbor and do the further troubleshooting. It could be a VCS Expressway or any other devices. Assume if your call indicates that the search rule hasn't found or it doesn't match, right? You can figure out the cause by looking into the view, right? Click on the view and you will have more details about what all actions that VCS has taken. So you may be having a fix in your search rule itself in order to resolve the problem. So always look into the search history when you're experiencing any kind of signaling issue where VCS is involved. VCS also has call history. So if you wanted to look at a previous call, what exactly happened to the previous call, so you can actually look into the call history, and clicking on the view will give you the details about the call, what all call legs were involved, and what was the bandwidth, and all sort of information related to the call which is being taken through VCS. Call status has a lot of details here. And also the call, you also have a running call status. So assume if the VCS is taking 10 calls at a time, you can go to the VCS call status. It will list you all the running active calls within the VCS. So click on that, click on the details and get details about your VCS active calls now. And also we have quite a lot of utilities called check patterns, locate, port usage. So check pattern would help you to check your search rules. So you are writing a search rule in your VCS and you wanted to confirm that it would work as you expected. So you can actually use this check pattern tool in order to verify your search rule. Locate can help you to confirm that your destination alias is matching an appropriate zone or it is appropriately sending to a particular zone. You can actually run that your destination alias using a locate tool and see what is happening with that particular destination alias. Right? Instead of just waiting for a real call to happen, you can do a test within the VCS. And VCS uses quite a lot of ports for its communication. For the firewall traversal or for interworking and various other things, it uses quite a lot of ports. So you can actually check and verify that all the ports are active and VCS appropriately using all the ports. We have that tools available. And also we have quite a lot of common tools called ping, traceroute, tracepath to check your network connectivity. Right? And DNS lookup is another important tool which you can use when you're working on a B2B call. So you can actually type your destination domain and get all the details about what all services that are being offered by your destination domain. Right? So if you're working on a B2B call, and you wanted to troubleshoot the problem, your B2B call is not working, and you wanted to check if the services and all these things, you can use this DNS lookup. Once you have done your analysis, now you need a TAC help. Download the logs from the VCS. By default, similar to the TC devices, VCS doesn't capture the debug level information. Right? So you need to enable the debug logs and then recreate the problem and then capture the data. So enabling debug, you can go to the diagnostics logging and you need to start new log, recreate the problem and stop logging and then download the logging. From X.1 onwards, you have an option to capture the TCP dump as well. So if you check that option, along with your diagnostics log, TCP dump also will start. Then you can download the TCP dump separately. The diagnostics log contain your SIP logging, SIP messages, complete details about SIP messages, 3-to-3 messages, all important debug level information which is required for you to troubleshoot the problem. So this is a bit complex to read. So when you share this information with Cisco TAC, we can look into these logs and figure out the root cause of the problem. I would say nearly 100% of the VCS related problems we figure out by looking into the diagnostics logs. It's a very important piece of information. So always when you suspect that your device, your call or signaling issue involving VCS, you suspect that there could be a problem in the VCS, always collect diagnostics log. Call manager. Make sure that in the call manager you enable SIP stack trace, CDR trace, SIP call processing logs, SIP keep alive traces and phone device logs by default, because that would help call manager to capture all the information when you have a problem. or always, call manager always capture those information. And you use RTMT tool to capture the data. An important thing to note down is make sure that your call schedule is falling within the range that you have given in the RTMT schedule. We see quite often that we get the logs from the customer, but the call information is not within that logs because they put a wrong duration in the RTMT tool. So make sure that we do that appropriately. Any questions? MCU and TelePresence server. I have some more left. So what is the latest version for MCU and TelePresence server? So one by one. Let's start with MCU. What is the 4?
4.4.
Yeah, 4.4. 4. Who was it? Okay. Oh, cool. TelePresence server, any idea? 3.1, that's cool. Thank you. Quite a lot of logs here. So we have conference status, event logs, sys logs, protocol logs, etc. So importantly, when you're troubleshooting a signaling and media issue, things to look at is the protocol logs. In MCU, we call that as a SIP or 3-to-3 logs. By default, these logs are not enabled. You can go ahead and enable these logs when you experience a problem. Once you enable the log, recreate the problem, and you have an option to download these logs as an XML file and look into that, or you can actually share with us for us to analyze. Same is applicable for TelePresence server. It has similar interfaces. In TelePresence server, it is called protocol log, and we also have an option to enable a specific logs, BFCP, 3-to-3, SIP or XCCP. You can enable or disable based on the kind of problem that you face. But I recommend you to enable all and see. You never know what kind of problem that we see, right? So enable all and collect all the logs and download. Now, we looked into these devices and see what all inbuilt tools are available, right? So now, packet capture. So as I said, the packet capture is necessary when you're working on media issue because the problem might cause due to some network issues. You may get into packet capture. And all of our devices has built-in packet capture is available. TCP dump is available. And you can either use that or you can do a port span and collect the information. But important things to note down here is do an analysis before you do a packet capture. Because in general, TelePresence issues, capturing packet, it is a complex process. The reason is you have to recreate the problem and set up everything. Then you have to recreate the problem, wait for the problem to happen. You don't get the problem. Then again, you have to go some other time and do it again. It's a time-consuming process. We recommend you to analyze the problem before we jump into this process. Let me tell you one of the example we had. Everybody initially think there is you need a packet capture, but it was not the case. So 1 year back, we gave a scary experience to some of our TelePresence users. So they were in a call. In the middle of the call, some pictures appeared, and completely unrelated pictures appeared to their screen. It was a frame from 2 days before call, right? The call happened 2 days before. That picture appeared on one of the current call to the users. Apparently, it happened to their boss's video conferencing call. That disturbed them quite a lot. So we got that problem in, and after our analysis, we figured out that there are quite a lot of packet loss in that particular call. Right? So first we thought, okay, there is a packet loss, go and do a packet capture. But we didn't do that. We actually did further analysis because the first problem description we had was appearing an unknown frame, which was from a previous conference. Right? That was the problem, first problem. So before getting to the packet loss and other things, we thought of analyzing that. We looked into the problem, and so these frames from the previous day's call, so frames must have been stored somewhere, right? Where does it store? Does it store in the network? No. it might possibly store in a remote end device, or it might possibly store in a local end device. It may be storing in an endpoint, right? So we did further discussion with our developers and see where all the possible cases where we store the previous frames. So we have a patented technology called packet concealment technology called ClearPath. As part of ClearPath, what we do is we store the previous reference frames. So these frames are used when you have a packet loss in your network. So what happens is when there is a packet loss, the previous reference frames is being used to conceal your packet loss. But apparently, there is a bug due to which the previous day's frames have not been erased from your flash. So there was a problem. So this has happened on a previous day's call. The bug got introduced or bug got hit on the previous day's call time, and it has not flushed. Your all stored video frames has not flushed. And now in the current call, they had a packet loss, so they referred to the previous frame, and that the frames which were not erased was playing back again. So that was a problem. So now, analyzing that, we figured out a bug. This was a bug, and we fixed that bug later. So this problem was not reproducible. It just happened a couple of times during the call. Right? So we saved a lot of time in reproducing the problem and capturing the packet. So what I wanted to tell in this case is analyze the problem correctly in order to identify, or in order to decide whether you really wanted to go for a packet capture or not. Packet capture, you can do the packet capture when you are experiencing the media issues. Signaling issues only when the logs are not sufficient. 95% of the time, logs are enough for you to analyze a signaling issue. But if the TAC engineer advises you to capture the packet on certain circumstances, you can go ahead and do a packet capture. Or any other related problems as we have seen earlier. Before starting the capture, do an analysis clearly and decide on the packet capture nodes. Right? And capture the devices from the areas where you decided that you really wanted to capture the data. So assume, for example, you have a problem on an interworking call. So remember, on an interworking call, the VCS will take the media, right? So at that time, you may have to go and capture the packet from the VCS, right? Most of the time, media may be going between two endpoints. So you will possibly go and download the data from these endpoints devices only. But there are certain circumstances the media is being taken through the devices such as VCS. So analyze that, identify those devices where you have to capture the packet, then go ahead and do a packet capture. Important thing, disable TLS or encryption before you start the capture, because it doesn't make sense to look into an encrypted data. And we recommend you to use port spanning whenever possible, and if you have infrastructure available, because it is always better to capture the data from the line rather than from the device. So otherwise, we also have a built-in packet capture tool available. You can leverage that and capture the packet during the problem is being recreated. Any questions on the packet capture? Okay. Now, so we concluded on the signaling and media issue. Now, we have another category of issue which is quite simple, but that is called system errors. Right? So, quite often the system errors are localized to a particular area or a particular device. Right? So, you may have a problem, a system error specific to VCS, specific to MCU, etc. Right? So, what all evidences that you can collect as part of your system errors so that you can identify the problem? So, I introduce you to these devices here. So, CTS, TC codec, VCS or conductor, TelePresence server or MCU. So, there are quite a lot of options available for you to capture, and we have the quality and ease of collection is described here. You can just use that offline. Starting with CTS device. CTS device has touch panel and options to check any system errors, web UI, and also we have diagnostics options available. In TX6.x onwards, we introduced a very few useful diagnostics tool, which you can actually check all the camera systems and LCU related errors, and you can actually run through the web UI and easily test your all peripherals and verify that whether you have any problem or not. So the test will look like this. You have an option to go to the web UI and select what kind of test that you wanted to do. Choose the display and choose your test, and then run the test. That will run the diagnostics commands into the device and give you the results. And we have options available for display, camera, and LCU. So if you experience any problem with your camera, run this test, and this will actually power cycle your camera, do various tests, and give you the final result, what exactly has happened to the device. Sometimes it can actually fix your problem by doing a rerun of your diagnostics test. And also we have quite a lot of diagnostics commands. Show commands and utils commands are available. You can leverage those in order to identify if any specific errors that you have in your system. An important thing about the diagnostics log is it not only tests, it also gives you a recommended actions that you can take in order to fix those problems. So one example is if you run an LCU diagnostics here, it gives you a set of failures, right? And if you see below, it gives you a set of recommended actions. Run thus, follow these actions, it can possibly fix your problem from the CTS device. TC codecs. We have introduced quite a lot of new features as part of your TC codecs from TC 6.1 onwards. So in general, we have touch panel, web interface, and command line interface for you to troubleshoot your system errors. But in the latest TC releases, we have a very useful feature here called diagnostics and troubleshooting. So here, when you go to the home page of your TC devices, just log into your web UI. If you have any problem on your system, it will actually give you an alert here on top, right? So this alert, if the system is all right, you do not have any problem, then this area would be blank. So if you have this alert, you can go and click on this link, and it will take you to the diagnostics page directly. Right? The diagnostics page will give you all set of problems. If it is good, it will give you green. Otherwise, it will give you red for errors and yellow for warnings. It's quite easy here. You can go and click on the configuration. If the problem is due to any of the configuration, it will actually open up your configuration page where you can directly go and fix the problem. Right? So as we have a problem here with the SIP registration, it would directly open the SIP configuration page where you can actually go and fix by clicking on the configuration link. It's all hyperlinks. You can fix the problem. Once you fix the problem, you can click on the rerun diagnostics, which can test your fix. And once you finish your test, if the fix has, or if whatever your changes you have done which fixes the problem, then these errors would be disappeared. It's quite handy, and that is available from 6.x onwards. You can use that. It's all, you can fix the problem by yourself quickly. And downloading the log archive. So if any system problems, system errors are occurred, you can actually download the log archive directly by going into the diagnostics and log files. Click on that. And system errors, you possibly may not need the call history, so you can download just the log archive and share with us. Remember, TC devices also store historical logs, right? So many times when we experience any problems, the normal tendency is to go to power off and power it on. Sometimes it may fix, but sometimes it may not fix your problem, right? So, but you are losing a lot of information when you are doing a hard power off or plug off. Don't do that. So if you really wanted to do a power cycle, always go ahead and do a power cycle from the maintenance and reboot. What if you do that process, what will happen is, it would collect all these logs and make a tarball and store as part of the historical logs, right? Assume you experienced a problem and you did a reboot, and that fixed the problem. But you need to figure out the root cause of the previous problem, right? So if you share the log with us, that would contain the historical problem also, historical log also. So we can have a look into the historical log and figure out the problem. So please be aware that. And also, if you look at here, so these are the current log. So current logs means it is since the last reboot. All the logs are stored here. But when you download the log archive, it will contain both current logs and the historical log. VCS and the conductor. VCS has, if you are using an appliance-based device, you have LED, LCD, which will give you if you have any system errors. And also we have a web UI, which has alarms, event logs, configuration logs, quite a lot of logs in order to identify any system errors. Important thing when you are working on a system errors, in VCS, we have something called alarms. So when you open to the VCS web UI, we see the top right, if you have any problem in your system, you will have alarms. Clicking on those alarms will take you to an alarm page. It will look like this. And if you look at here, the actions would take you to the area where you can go and fix those problems. Assume if it is a configuration related problem. Clicking on actions, hyperlink would help you to take you to that particular configuration and you can fix the problem. If it is a cluster related problem, clicking on that would take you to the cluster device where you can fix this problem. It's very handy and it's very useful when you are working on a system errors. And also we have alarms ID. So every alarm has a unique ID. So that is also hyperlink. If you click on that ID, it will take you to the event logs where it will list you the events which is causing that particular alarm. So you can troubleshoot that in that way. So if you have an alarm, click on that link, it will actually give you an event log list which all events which is causing the problem. So see what is causing and appropriately you can actually fix those problems. And that will give you some kind of trigger or it can help our TAC engineer in order to analyze the problem. Right? And of course, event log is a good piece of information we can browse through. If you experience a problem, go through the event logs and see if anything suspicious that you observe. And you also have an option to download the event logs. Very critical information is for this VCS is system snapshots. So this typically you cannot read those information, it is a bit complex, but when you wanted to report any problem with Cisco TAC, the important piece to collect is system snapshots. So we have three kinds of snapshots here. One is status snapshots, which contains the status and configurations, and we have log snapshots, which contains the logs, and we have full snapshot, which contains quite a lot of information, including your logs, your sysinit logs, core dumps, cluster DB database, and your disk usage, inode usage, and quite a lot of information available as part of this, as part of your snapshot. So now, when you download the snapshot, it may possibly take 15 minutes to complete the process. So this is complete replica of your VCS device. You are actually taking as part of from the VCS. So always make sure that you download the snapshots when the system is not in a fully operational mode, because it possibly may impact the performance. But don't worry, all these informations are available. It will not get overwritten because all the complete information about your system and what was the performance and your disk usage and memory usage and all these details are available. When you experience problems like high memory usage or high CPU usage, it's an important thing to collect. An MCU and telepresence server. So MCU and telepresence server has device LED status available and system status, health status, and there are quite a lot of information available in order to troubleshoot the system errors. Right? And the important things to download from your MCU and telepresence server is diagnostic information. So when you go to the home page of your MCU or telepresence server, you have diagnostics logging information available, and you can click on that and download it. That is a very essential for troubleshooting the system errors in the VCS and telepresence server. And also, we have event logs. So looking into the event log can obviously give you some sort of clue what exactly is happening as part of your telepresence server and the MCU. So the telepresence server and MCU has a similar style of logs, and both are almost similar, which has, you can go ahead and do a download directly. And you can actually read it as a text if you wanted to look offline, and also it is available from your web page. Right? You see a lot of things like errors. So these descriptions can give you some sort of clue what exactly is happening in the system. Summary, we talked about a 4C methodology which can help you to troubleshoot your problem effectively. Clarify, classify, confirm, and checklist. And we also looked at what all evidences that you have to collect for your further analysis, and specifically for each category of problem. Signaling issues or media issue, what all specific information that you have to collect as part of your diagnostics. What we have to do and fix. So analyze your cause, question your cause and question your fix, and then appropriately apply your fix based on where all the cause is applicable so that you can fix in all these places. Talked about troubleshooting tools, the useful troubleshooting tool that you can actually use as part of your diagnostics. Any questions? Hope this session was informative for you. So, any questions? Yeah.
On the TC CLI, I hope I know the answer is, but couldn't find it. I was trying to do a remote reboot or factory reset on the CLI. I could not find the command on the CLI. Is it under X command?
Yeah, you have an option in the X command. Typically, some of the commands like factory reset and these commands are hidden because we do not want that by mistake users or administrators do, but these commands are available. So we have for factory reset and reboot, we have commands available. I hope it is available as part of our admin guide. If it is needed, I can actually share. So we have some, also in the subsequent slides, I have some appendix where we have quite a lot of references available. So we have something called handbook. So VCS and endpoint handbook is available. I have given the link as part of this session. You can actually get the handout. So that has a detailed handbook which contains all the information about these kinds of commands.
CTS is it's right there under, I think, utilities, but on the TC I couldn't
It is,
find it.
yeah.
It had to be there. I figured it had to be there.
Yeah, but the handbook is available, so the handbook has it. So yeah, so handbook has it. So that link is available as part of this presentation in the appendix. You can use that. It is available. So this factory reset and restart is available as part of your command.
Factory reset I can understand, but restart,
It is. Both are available. It's not. But some of the releases they actually hide it in the latest releases just to avoid by any issues by mistake. It usually they hide it, but it is available. So I can actually give you, maybe if you can contact me later, I can get the exact command. Yeah, it's an X command. Yeah, it's an X command. X command. Yeah. Okay, thanks for the questions. So any more questions? I have some more goodies available. If any questions, I can actually give away those. Yeah. Yes. Yeah, so now typically these devices are deployed across various regions, right? So US and so usually telepresence systems are meant for the remote access and remote communications, right? So deployed across various time zones. And so when you compare the logs, say for example, I have a log calling from one place to another place. When I compare the log, I don't want two different times, right? So just good questions, yeah. And please feel free to fill the surveys. And so we need to have 5 surveys filled out for you to get a T-shirt. Right now it is available. So please fill the surveys. And if you have already filled the survey, 5 surveys, please fill the 6th one. So don't forget.